Hello viewers, here is that Lasko Cool Colors box fan that was getting tossed out. The blade has broken off. You can see missing from the top there. It's inside the bottom of the cabinet. And the motor does not run. So my theory would be the blade broke off somehow and the rest of the propeller sat in a locked state, and so the motor just kind of overheated and tripped the thermal fuse. So if my theory is correct, a simple fuse replacement should revive this fan, and I believe the blade broke in a way that can be glued relatively easily. You know, you may ask, why bother? I don't know. It's just a project of curiosity to me. I'm partially curious to see what the motor looks like after it did fail, probably from an event of overheating. And I mean, I gotta admit, it's kind of cool. How often do you see a blue box fan? So whatever. Anyways, let's get inside this thing here. I was going to originally just scrap this for parts, but I think I can save it, so I'm gonna try. Oh, that took a good beating. It's missing quite a bit of the top there. Well, that may cause it to be out of balance. Let's see here. Yeah, each of these blade tips is jacked up pretty good. I'd probably put up a decent fight when the blade broke off. Well, let's see what we can do. This may not be an issue because there's going to be, you know, the weight of the glue on this blade, so who knows. Let's see if I can get this blade off of here. Okay, that wasn't too bad. So, you know, with the way it broke, there's a lot of surface area to glue to, and if I put some really powerful glue on there, you know, it may be alright. I don't know, but we'll see. So here's the motor. I have to say, these look like they're relatively well-made motors, and if you keep them clean, they do seem to hold on for a number of years. So let's see. I don't know where the thermal fuse is located inside these motors. It may be inaccessible, but if it is accessible, we'll give it a test and see if it's open or not. Okay, and what exactly did that release? Oh, that released the motor. Okay, that's not what I was expecting it to do, but that's fine. I'm gonna have to drop this part too. That was a little deceiving. Okay. And we got a separate screw for the capacitor. Alright, So let's see if we can get inside this motor and see if we can locate the thermal fuse. Actually, you know what I should do before I do that is check the plug, because of this fuse one, that's a much easier repair. Got my multimeter here. I'm going to put it into continuity mode, or not continent, whatever it is. I don't know. I'm tired. It's late at night. I had the early shift today at work. So what I'm going to do is I'm going to put one probe on one prong and the other probe into the switch here. If I can access it, I think I got to take the switch off. I don't know if this still detaches the way the old ones did or not. Yeah, it should. It should turn and come off here. There we go. Ouch. Okay. So that's off. Now this is stuck again. Okay, and we're back. Minor disruption there. Okay, so the switch, we can see the wires a little bit here. So what I'm going to do is take one of my probes and put it into there. I'm going to take the other probe and, well, the meter's got to be on first. That's definitely one of the prerequisites here. Okay, so there's continuity there. Now let's check the other side. And that's good. So the plug, the fuse in the plug is working. And I don't like that these aren't replaceable, but to their credit, I have yet to see a scenario where the fuse actually blows in there. So, you know, maybe it's not such a big deal. Anyways, okay. So to get into the motor, we're going to undo these 4 screws. It looks like these aren't going to be too hard to get off at all. It's a nice surprise. And the shaft looks pretty clean, so I'm hoping that this will just slide right off, and then we can access what we need to access. Okay, that was easy enough. Here's the shaft, and there is a lubricant on there, which is good to see. It's incredible how small these are, really. And here is the stator, which is what we need to work with. And I think I can see the thermal fuse. It's time to zoom in a little bit here, reposition the camera. So I believe that there's some dust on here. It's a little caked on there. This must have been used near moisture. But I believe that this white thing right there is probably the thermal fuse. So I'm going to cut this tie wraps off. These tie wraps, whatever, like I said, I'm tired. I'll get this one off too. And then we should have a little bit of slack here to work with. I can get this to come off. There we go. And so, let's see here. So it looks like we're going to have, should be 3 separate windings in here for a 3-speed motor. Let's see, what do we have here? Yeah, I really think this may be the thermal fuse. So what I'm going to do is, hopefully without anything breaking, I'm going to try to take this off. Okay, there's that. I don't like how easily that came off of there. And I'll take this off. I don't like how easily that came off of there either. And I believe, yep, I can feel it in there. That's going to be our thermal fuse. So again, I'm going to go in here with the meter, put it back in continuity mode, or whatever it's called. I know how to use it, that's really all that counts. And let's see what we have here. Nothing. Open. Totally open. So, what we're going to do, and this is just to test my theory, this is not to make it run again. To test and see if this is the problem, what we're going to do is we're going to take this out of the picture. So I'm going to go ahead and cut this off. And just make sure this is it. This is the thermal fuse here. 2 amps, 115 degrees Celsius. I don't think I have one that's so low. 115 degrees. I'll have to check and see what kind of fuses I have. But just to see if it runs, what we're going to do here is I'm going to just join these two wires together. And if it runs like this, then it needs a new fuse. If it doesn't run like this, then there's something else wrong with it, and I don't care what that is, because it's not worth the time. But I will give it this much of an attempt to fix it, because I think it's worth a few minutes to replace the fuse. Now, it's going to be kind of weird getting this jammed back in place without breaking anything. I think this is just kind of like this. And of course, if this was the final, oh, actually that right there, that may be some evidence of heat. This wants to unblur. You can see right there that has like the pattern of a winding where it would have been resting. But this is not, you know, hard to melt. This is just like a plasticky tape kind of material. So honestly, I have to say, if that's as hot as it got, I think this is relatively safe. Again, that's assuming, which is very dangerous to do, assuming that the protection is going to work, and it's going to work every time, which I don't necessarily believe is going to be the case, but it worked in this case, so we'll give it that much. And now we're ready to slip it back in place here. Try to be careful that that doesn't enter into the space where the rotor is going to be rotating, because that's not going to work too well if it's in the way. And I think that'll be alright. Just kind of push that off. And again, if this is a permanent fix, we'll do better, but for now, I'm just going to push this off to the side here. Actually, you know what I could do is just take these and stick them out the back. Because it doesn't really matter at this point where they are or what it looks like. That provide enough clearance for that to run. Slip this back in here. And this does need to be cleaned, but it's good enough for now. And does this go? It should go like this, I think. Yep. And I'm just going to put 2 opposing screws in. That'll be good enough just for the test. It should have been oiled, but you know, again, this is just a test. Okay, so I'm confident that this should run now. So I'll prop this up on there and turn the switch to an on position. I'm going to make a valiant attempt to, anyways. Okay. And let's see if we get fan or flames. Neither. We get nothing. That's a little surprising. Unless I happen to turn the switch into the off position, which is not inconceivable, I guess. I don't think it's in the off position anymore. Nope, we still get nothing. Huh. Well, that's a little surprising, actually. I thought it would just be a simple thermal fuse replacement. I don't know. Well, just out of curiosity, because I don't give up that easily. Let's see what kind of ohms we have through the windings. Maybe somehow they're open, I don't know. Let's see what's going on here. Huh. It's still open. So it's like the circuit's not getting completed at all. Okay. So there definitely is open load through the mains. What in the world? How does this even happen? Alright, so let's check the switch. So we're going to have, let me look at the cord here. So this is the high side, and that's going to be the non-striped side. So non-striped is our input here, which goes into the switch, and then it gets sent to one of these 3 windings. So we want to measure from this winding, which is the low end from the motor, and we're going to check winding number 1. It's hard to kind of jam this in here, but I'm going to try. Okay. So either that's not making contact, or it's an open load situation. I want to see if I can get the wires out of the switch here. Usually this can be removed without too much grief if you insert something in there at just the right angle. Exactly what that angle is unbeknownst to me in this particular switch. Let's get the light on here and see if I can get a closer look. I don't know. There we go. So that's speed 3 high, and then this is the common or neutral or whatever you want to call it. The switch is calling it neutral. This is vastly more difficult to remove than I think it should be. Okay. So now that I can be certain we're getting a good connection, well, we're getting something there. It's very, very minimalistic though. Okay, about 300 ohms. That's not that far off from what it should be. So why then is it not running? Unless the switch is spoiled somehow. Though that I find that very unlikely. Well, alright. That's odd. It's really odd. Now let's check the switch. See how the switch is working. Certainly should not be any connectivity here other than one setting. That's kind of unsettling, actually. I don't know what's going on with this switch. I wonder if there's something wrong with this switch. Let's do this. Let's forgo the switch. I'm going to remove the wires, and I'm going to go directly into the leads. See if I can get some results that way. Alright, so I'm going to take these leads and connect to the leads of the cord and see what happens. Okay, so now let's check the continuity on the cord and see what we're getting here. Open load. What in the world? So there's something wrong with the motor still. this thing has got about 15 more minutes of my life and then I have to go to sleep. And I think at that point we're just going to call it done, because it's not worth the time. I don't see any broken wires. I can't imagine there's more than one thermal fuse. The only thing I can think of is this connection that I made here is just not very good, and admittedly it's not, so let's patch it up here and see if that makes any difference. Okay, so now we're getting an ohms reading. Seems about right. Getting some ohms. So let's put it back together again, although of course now it's not going to fit into the housing. Maybe this will make it fit. I think that may fit actually. Okay. Alright, let's try that. There's my plug at. So we have about 103 ohms, which I think is a little bit more of a normal, well, it's definitely more normal than 0. And there it is. Alright, so now what I want to do is put the switch back into the picture, which I think was falsely diagnosed as spoiled. And then we'll check and see if all 3 speeds run. I find these never hold quite the same once you pull them out, but I don't think it's beyond what's usable. Okay, so that was low, let's test medium. And actually we can go through the meter test first, because it should have different resistance values per speed. You know what, I still kind of think this switch is a little wonky. This shouldn't be fluctuating like that. It will flux because there's a capacitor in there, but okay. Yeah, we're gonna go with it. I think it's safe enough to plug it up. Okay. And now this should do nothing. It's off. Alright, so it is going to be a thermal fuse replacement. So I have in this box some thermal fuses. And nope, that's the wrong box. They're in the other box. It's the glue box, they're in the soldering box. I have in this box some thermal fuses. Let's see, I forget what these are rated at temperature wise. These are overkill in the sense that they are for 15 amps. Where did the other one go? So the old one's 115, this one's 113. Oh, perfect! So that's good, so we'll put that in there. So now I'm going to get the soldering iron out and see what we can do. I just washed off the blade, so while that's drying, we're going to go ahead and rewire the motor with the new fuse. I'm going to have to find some tie wraps. I know I had some somewhere, but I just cleaned up recently, so who in the world knows where they are? Yeah, I'll find them. Okay. Alright, so this should be pretty simple. All we gotta do is get the thermal fuse in between. Oh, I didn't turn the soldering iron on. Okay, well, it's gonna take some time to warm up. But all we gotta do. Oh, was that my last thermal fuse? Yeah. I don't recall replacing another one. Well, I have to order some more thermal fuses. Anyways, what we're going to do here is just get the fuse connected in between there like it was, and then this should be safe to use and working. Well, I guess while that warms up, I washed the blades preparing for the glue, so that's going to dry. I guess I just got to search for those tie wraps now. So we're going to need to put some string tubing over here because there's going to be a portion of the fuse's leads that are unprotected, so that the string tubing here is going to take the place of, where did it go, of that kind of cloth like material that was over the other fuse, which is now MIA. Ah, here it is. Losing my vision. This stuff, because this is too small to fit the other new fuse into. So we're gonna put, I've just put that on there and that's good enough. So let's see here if soldering iron has warmed up enough. What in the world is that? Where did that come from? Alright, I think iron's on a little too high. I'm going to turn that down a bit. I'm not exactly sure what the heck that is, but it kind of brazen the top of the thing there. Jeez. For heaven's sakes, I just got that thing too. Ugh. Alright, well I guess it's hot enough to be ready. Now I always get nervous doing this with thermal fuses because I did this once, so the fuse got too hot as I was soldering and then the fuse blew before I could even put it back into service. So I'm going to try very hard to not have that happen. And that's why I'm trying to use a lower power on the iron too. I'm going to turn this down again. Okay. You know, we're going to redo that. Well, obviously, because that was a major fail, but I want to strip this and redo it because it's kind of screwed up here. I don't think we're going to have any good results trying to solder to that. Okay, I believe this is probably 18 gauge wire. Might have been 16, I don't know. Or 16, whatever the undersize would be, 20. Alright, let's try this again. I don't know what's going on with that black stuff. Very odd. Well, you know what? Let's do something a little differently here. Let's, I mean, that's okay, I guess. It's not really what I wanted. Let's see if I can kind of compact this a little bit better. I would have liked to have it like kind of twisted, if you will. Well, there we go. There's no my opportunity to fix it. It's going to be very hard to do this because these are both solid wires, not stranded. So trying to get these to twist over each other is going to be kind of interesting. Dog is having an outburst tonight. I don't know what the problem is. Got to be animals or something outside. I don't like working with solid wire. Stranded is so much easier. But this is solid, so it is what it is. Alright, that's what I wanted. So now I can just fill that in with the solder and we'll have a really good connection. Now it's not hot enough. Now it goes from too hot to melting itself to too cold to melt the stinking solder. And this isn't even an issue of my soldering skills. This is just a user error on the equipment here. Okay. I am much happier with that. Yo, she's got to chill. Okay, that's what it looked like now. So, the other side is going to be a little bit more challenging because it's got the winding lead on it. And, so we're just going to have to exercise a little bit more caution here. If any of this breaks, it's just going to complicate this whole thing. Okay, good, that's not getting too hot. That's kind of sharp there. I want to dull that out before I put the shrink tubing on, otherwise it's going to break through it and cause a short. Okay. So again, we're going to have the issue with not being able to get the wire to wrap around the thing. Oh, this is actually stranded wire, so if it weren't for the fact that the windings were attached to it, it would be relatively easy to make this connection. What in the world is her deal? This is just being extremely difficult to work with. And I'm very worried I'm going to end up breaking one of these lead wires here to the windings. Alright, that's pretty good. Let's see if we can get some solder onto there. What happened to the solder? Here it is. Can't believe that just happened to my stinking thingamajig there. That thing just got pretty hot. I gotta stop and let it cool off. Okay. Alright, so let's do a quick test on the ohms. See if we still have functionality here. Yep, we do. And suddenly the readings are as stable as can be on the meter. 103. 87 and 72. Alright, so that should run now. Now the fun part is going to be getting everything to fit back in the motor housing there. So I'm going to take a break from that for a moment because I want to have this glue drying while I finish that up. So I believe, whoops, that this should be fairly easy to glue, and I think it has enough surface area that it will stay. It'll get a good hold. Now I just cleaned it. I cleaned the broken area with Dawn dishwashing soaps. So all the, any grease or contaminants should have been removed from the surface. So I'm hoping the glue will get a good strong grip onto this. So I'm going to start with the left side of the blade. I'm going to paint some glue on here, if you will. Actually, I have to do the whole thing at once because the way this is, I don't think I can get any glue. Jeez, now I gotta go quick. I hate going quick because when you go quick, you make mistakes. Okay, I think that's enough glue. Put that back and stick this on. Hopefully not get my finger stuck to the stinking thing. Okay, I think I'm done gluing that, so I'm just going to let that sit for a while. I tried to fill in the cracks as best I could. See what happens with that. So now, let's get the motor put back together. I found some tie wraps. I'm not sure if these are going to be small enough. Let's see if they are. Yeah, I guess they will be. Okay. So, I'm going to bring the shrink tubing up over the thing here. And I'm going to pass it a little bit over this way. And I'm going to try to get a good bend in this so that I can put this thing back on, because we kind of need that to make the connections here. Okay. Well, it's not great. Maybe I'll forgo that other one and we'll just use the string tubing on that side. I think that's sufficient. I think that'll suffice. So now, this is where it's going to get a little interesting, because this fuse is much bigger than the other one. Now I know that this was sitting in here like this, and that's fine. I think we can get it back there relatively easily. What's a little concerning is fitting this gigantic fuse back into here. What options do we have? Oh, this suddenly became much harder than I thought it was going to be. I could put it like this, but I think the problem here, of course, now we're walking on thin ice by flexing this so much. I think it almost has to come Actually, you know what? No, I thought we was going to have to cut this off, but we can do this instead. We can just completely forgo those things. And, well, maybe not completely. Mostly forgo those things. I'll put another bend in here. I'm trying to remember how this thing even went now. Can do that, and then put this over here, although it's a little small for the solder to fit in there correctly, but we'll make it work. So maybe now I may have to extend this lead wire a little bit. You know, I think I'm just going to go ahead and do that. So we're going to have to extend this lead wire. That's fine. That's easy enough. Let's say we're going to put this here. And where's the bulb? It's right here, so I kind of want to position it such that the bulb is right up against the winding. Kind of like that. And then this will just get pushed in under there, like so. And I'm going to try to keep this on the outside because I don't want this blocking all the airflow from the windings. Maybe I'll put this on the outside too, kind of like that. So just the bulb can of the thermostat, whatever that thing is called, can go over the winding like that. And the neck can go there. I think that's pretty good. Only thing is weird is where does the capacitor leads have to come out? This wire, you know, I'm going to make a connection to that right now because if I don't connect it now, it's going to get forgotten about. Oh dear. What's wrong with this light bulb? I hope that light doesn't quit. Okay. I'm gonna have to finish this up tomorrow. I'm getting too tired to finish this tonight. Alright, so what we're gonna do here is I'm gonna strap the bulb of the thermal fuse, which is right here, right onto this winding. And then I'm going to have this kind of return, if you will. I think that's going to end up being the neutral line, but we'll have that kind of come back and sit like that. So here we go. Inherently, these tie wraps don't work as well as I would have liked them to. Okay, so that's right up against the winding there. And I'm going to have this kind of sit on the outside, because I'd rather have as much air going over the windings as possible. So we'll just block that one for the thermal fuse in case something goes wrong. And now the other wires, what I'm going to do here is, this winding is making me a little nervous. Pull this wire back up. Just going to sit this in there like that. And I'm going to take this and these two wires, I'm just going to kind of situate on off to the side here. So, you know, the tie wrap here. And okay, so this has to come out here with the rest of those wires, and that's fine. Actually, it's a really good length. And I'm going to take this tie wrap and stick this through here. And I'm going to strap down these wires. Yeah. It's a lot of wire there. But I think it'll be okay. The only concern is that this tie wrap may kind of enter the path of the rotor, but hopefully not. Maybe not. No, actually I think it'll be okay. Yeah, because it'd have to go pretty far back to do that. I don't think it does, so I think we're okay. So, that was complicated. Alright. Now I know the motor still has to be serviced, but I want to go ahead and close it up and give it a test run before I proceed any further. So I want to make sure that it actually is going to run. I guess I should cut this off the ends here. Yeah, this is having a tough time fitting back in here. Unless, of course, I'm aiming for the wrong holes, but I don't think so. Let's see if this is sitting here. And with this. Yeah, it's got to come out like that. Okay. Perhaps connecting that wire there was a mistake. I guess it'll be okay. It's just a little tight for my liking, but not everything is going to be perfect here. It's really having a hard time getting back in place. It just doesn't want to go. Part of it. Come on, bro. Alright, I think that's in. Nope, it's not in. Daggone it. I don't quite understand what's blocking it. It wasn't that. Something over here. There's a problem with this. I'm guessing maybe it has to kind of go up like... Oh no, that just broke. Ah! Okay, that's not a fatality, that's just an annoyance. Well, hey, maybe it'll fit now. I gotta get that piece out of there though. Alright, let's see if that'll fit now. I think that was the problem actually. Yep, and that was the problem. Who would have thought a little piece of plastic would cause so much grief? Well, such was the case here. It shouldn't be hitting the tie wraps. Nope. Oh man, it's almost 10 o'clock. Correction, it is 10 o'clock. Good grief. Alright. That looks right to me. So now, let's see if I can pull this lead off of here a little bit more. I'm gonna do that and make a connection here. Done with the meter for tonight, I think. Oh, that's just lovely. And what I want to do is just do a quick test. And I'm going to go to sleep, go to work, and then come back this tomorrow. But I think at this point it should operate, and it should operate on all 3 speeds. Or it could blow up, that's always a possibility. Oh, it runs. Let's check every setting. Okay. And that should be off. Yep. Alright, so that works. That's it for tonight. We'll reconvene tomorrow. And we're out of memory space anyways, got 4 minutes left, so good stopping place. I gotta stop anyways. Alright, so it's actually 2 days later. I didn't have any time to look at this yesterday, so we're picking up again today. So I believe where we left off was needing to put the motor back in place, fix this, and then remount the capacitor. And let's see here, it looks like the... I'm going to take this off all the way because it's going to make it easier. So it looks like this, if I had done this 2 days ago I'd remember, but such just was not the case. So it looks like that is how it goes, but then how exactly does it, because the whole thing didn't get any shorter. It's got to sit like that, but how could it if something just doesn't make sense here, because this is the only way for the motor to sit in here and the wires still reach, is like this, but this piece has to secure like this, and there's no way, it's got to come down like several inches. So unless I reassembled the motor inaccurately, which actually, you know what, I think that's what happened, because I could rotate this front part and then these mounts what was that, 90 degrees, and get the result I'm looking for. So that's what needs to happen. So I'm going to do that now. And you know, at this point, since we're already going to be into the motor again for who knows how many times in the last week, I think I'm just going to clean and service the bearings this time. I was going to wait and do a separate video, but I guess there's no point. I will just... So this came off like this. It really needs to kind of go on like this. Okay. I think I'm just going to clean and service the bearings now, because I don't feel like going back into this motor again. It actually looks pretty clean. I'm not too sure why it's having such a problem, but the spin down time is awful. Actually, there seems to be some lubricant down here as well. These motors aren't really known for locking up. Alright, so that's that. Here we go, you know the drill. Oil for fans, that's why it says fans right on the container. I think this video is long enough and there's no reason to drag that out this time. Okay, that should be better. I'm going to screw it in like this, and I believe this should now give me the mounting that I want. Yes, it will. Alright, so that was a user error situation there. Alright, so now I'm going to close it back up, hopefully for the final time. And I'm hoping the spin down time will get better now. Yeah, it's a little better. Still not ecstatic about it, but it's better than it was. Alright, I think that's satisfactory now. So now, I think we got to turn it back over again, and I'm going to screw on this thing. So this plastic thing is actually what holds the thing in place, the motor, which is a little bit unsettling. I always, so at least on the old ones anyways, the motors are always attached right to the metal bars. I guess that's a thing of the past now. Now we attach to little plastic rings. That's the right screw for this. I think it's gotta be, because this, yeah, that doesn't fit in there. Oh no, it does that. Alright. Okay, those are all the guard screws, I think. This is why I don't like projects to go on for multiple days, because I start to forget what happened. I'm not understanding why there's 5 of these screws, and well, okay, we'll figure it out. Okay, so now something else is wonky here, because I don't think the capacitor is going to reach now. But that's weird, because that's not even a function of oh no, actually it'll reach just barely. That may be a function of the way I set the wires up inside. Okay, and now I think what happens now is these screws are going to go through here and thread into the motor, which I don't really like that, because they're not machine screws. Well, actually, I guess they kind of were, I don't know. Actually, that threads in just fine. And it's not the right screw. So then where is the right screw? Perhaps I put the other larger screw into the capacitor slot. Yep, I think I did. Another user error. If I didn't jack up that hole. Okay, that's more like the way it's supposed to go. Alright, pull this off. This needs to go back into place. And that needs to not come out of there. I'm not exactly sure how I got this out with the wire attached. certainly an item of curiosity now. I think that's supposed to go like that. That's the only physically plausible way that the wires are all going to fit. So here, just to confirm, the non-striped side is the high side. So that's going to go into L. And then the other side will go into here. Alright, that's all in there. Okay, that's good. And this, you know, this should be shrink wrapped and done better than this, but this thing is consumed whatever enough of my time that I think it's just going to sit like this. And honestly, that's perfectly fine. I don't think that's ever going to be an issue. In fact, I'll even tuck this under the other wire, and yeah, that's how it's going to be. Because I just have other things to do. So, let's put the switch back on. And let's put the blade back on. I just added another coating of glue here, but I think it's good. It's pretty sturdy. I think it'll be okay. So put this on here. The only thing I think that could go wrong is you may have a noise because of this. And I might have to go in there and sand. Oops. This lack of there's some sharp points here. It's not even, so I may have to go in here and sand this down so that it's more level and even. But it may not matter. I don't know. I don't think there's enough missing material for it to be a balance issue. Okay, so let's plug this in here. I'm kind of nervous to run it up with the guards off in case the blade flies apart, because you know it's a possibility that could happen. All right, it's plugged in now. I'll start off on low. Oh, for heaven's sakes, it doesn't work. Well, it worked not that long ago. Alright, this is really getting out of hand here. What has gone wrong? I'm going to guess it's something with the switch. totally open. Alright. So let's see, we should be getting line. Of course, this is very difficult to manipulate now that the thing is put together. If the switch is working, we should have this terminal going to 3, which we have. This terminal to 2. Can't get the thing in there. Let's try number 1. Okay. 1, 2. That's not right. Why is this connecting everything? Switch, once again, is seemingly odd. Okay, well that could have something to do with it. That seems to have broken off. Now I don't think that happened before. I think that just happened now as I went to remove it. It's going to be interesting getting that out of there. Interesting or nearly impossible. This is definitely going to turn out to be one of those projects that just does not want to work. Okay. Now, since I don't know if the switch is broken or not, I'm going to do a couple more tests with the meter on the motor and see if we get the normal readings or not. Go back to ohms and let's see what we have here. 102, 87, and 72, which is what it should be. That's what it was before. So I tend to believe there is something wrong with the switch. I don't know what exactly it is. You know, it's a relatively simple mechanism. I don't know why, you know, or what exactly is going wrong with it. there should not be continuity on all three settings. So I think it may be safe to say this switch is spoiled, which is outrageous. But it does seem to be the case. Now I can't get the meter out of there. Now I believe I happen to have another switch floating around here, because I had some parts from another one. I have this switch here, which I really would rather use that for a different project. I want to remove these wires from here and test it without the wires, in case for whatever reason maybe something is just jammed in here too far and that's, you know, causing an issue or something, because the switch really hasn't taken any abuse here. I don't know why it would have quit. It should not have quit. Okay, this will be the switch just by itself. What it should be doing is taking the line and distributing it only to one at a time. Now we're getting nothing. Yeah, I don't know what is going on with this switch. Something definitely isn't quite right. Alright, so I just inserted everything so that I can still contact the wires, and we try again in case it just wasn't making a connection here. So there's 103 ohms there between the line and the neutral, and everything is live. So this switch is spoiled. I don't know how in the world that happened, but it happened. So I'm going to have to get another switch. Don't know when, don't know where. Fortunately, this is a relatively common switch. It's not a weird, you know, number of speeds or an odd size. So I can probably get one somewhere, but just for the purposes of testing functionality, I'm going to go ahead and hotwire this just so that we can power it up and see it run. Make sure it does actually run, because I certainly don't want to buy a switch for something that doesn't run, although a switch is pretty universally used. You could find something else to do with it. Way more difficult than it should have been. So in this case, we're going to take the high side which is this side, and we're going to put this to a winding. That's going to be high, this should be low. Put this to a winding. And we'll take this and put this to common. And that should spin it up onto low. All is well. Oh, what, it sounded a little weird there. That is working. I'm just going to cap off these other two. Shouldn't matter with the motors in good condition and everything. These should have absolutely no connectivity to them, but I don't necessarily trust this thing just yet. That's too big. So let's put this one here. And let's get the paper clip out of there. And put this onto here. Okay, and I'm going to hold the guard in front of it again just in case it, flies apart or something. I don't know what to expect here. And I'll plug it in. It's shaking a little bit, but not any more than I think is typical. Doesn't necessarily sound annoying either. Alright, that seems to be okay. Let's go up to medium. So I'm going to switch. See, this is going to be medium, so I'll just switch this out. Take that off. And why is that so dusty? And we'll connect this. You know what, we'll just go straight to high, because if something's going to happen, it might as well happen now. I think this is high. Alright, here we go. If the blade's going to fly apart, it's going to do so now. Seems to be okay. Well, it looks like it'll be okay. Yeah, it doesn't seem to have let go at all. Actually, it seems quite sturdy. Not any less sturdy than the rest of the blades, really. Yeah, it shakes a little bit, but I think all these do. I don't think that's really an issue as far as the broken blade goes. Alright, well, now all we gotta do is get a new switch. I'll work on that, and then I think we can finally close out this video. So it's like a week later at this point, and I have sourced a new switch. This was relatively inexpensive, and it came with a coaster. Or so it claims. So let's see what we have here. These scissors hardly cut. I should just get another set that actually cuts. Okay, it did in fact come with a coaster. Add that to the collection. I must have 50 of those because they ship with batteries too. So here is the switch. And interestingly enough, the dial kind of reminds me of the dial that would have come on the metal Lasko box fans. Well, a little bit, I guess. Anyways, fortunately, it's probably going to fit in here without any trouble. Yeah, it is. Okay, that's really great. Now this may not fit on here without any trouble. Yeah, this is going to be interesting. Because this is a little bit different in size. Can I just jam it on there? Well, yeah. So that's... Normally I wouldn't do that, but for this kind of an application, that's what we're going to do. And so yeah, so this switch is not an exact replacement, it's a comparable replacement, but the difference is this switch does not feed through the low side, whereas this one feeds the low side through the switch. So we just have to wire it a little bit differently. Minor difference to the way it's going to assemble. So what we're going to do here, actually I got to find out what speed is high. I think this is high. Let's just plug it in and check. I think that's going to be high. Yeah, that's going to be high. So we're going to start with this. That's got to go into 3. I think. Yeah. I don't know if this switch goes 1, 2, 3 or 3, 2, 1. Yeah, actually there's a relatively easy way to find out. Instead of guessing, let's just check it. So, let's see here. In this position, it is off. Oh no, it's not off. It's on 3. So now let's see. That should be off. So the first setting is 1, which is not the way the switch is labeled. I'd rather it go 1, 2, 3, as in low, medium, and high, but the numbers wouldn't match on the switch and that would annoy me. So it's going to be the same way it was originally, going from high to low, but it's going to, the highest speed has to go into number 1, which is a little counterintuitive. But anyways, that's what it's going to do. So, let's begin. Let's get it in the picture, that's valuable. So the first connection we're going to make goes into 1, and then the second connection is going to go into 2, get in here today. Okay, and then the third connection is going to go into 3. line. I want to confirm that's the high side. Yes, it is. Ideally, this should probably be soldered a little bit before entering into the switch, but I'm going to see if we can deal without that. Okay, I was able to deal without that. So, let's do a test run now. And this is the low side, which is just going to be like that. So this should be off, which it does seem to be. This should be high, which it does seem to be. This should be medium. And this should be low. Alright. Let's just verify one more time with the meter that everything is working correctly. So I'm going to stick one lead into the high side, and we're going to go, we know off worked, so this should be here and nowhere else. Uh-oh. What the heck? Okay, you know what? Clearly something, I don't know, whatever, I don't understand that, but it seems to be working okay, so we're just going to go with it. So, what I got to do now, because this cabinet's kind of dirty, I want to strip everything out of it and wash it. So I'm going to remove this wiring if I can. It's pretty sticky. Remove this wiring. I'll pull the blade off, pull the motor out, wash everything, and then we'll come back and put the switch in. It's all been washed. Actually cleaned up relatively well. Finish is still pretty decent. So now we are ready to put this the motor back in and put the switch on, and hopefully conclude what I think is going to be the longest servicing video yet. Actually, the longest video in general of any kind. Would have preferred the longest video to be on a little bit of a better topic than a cheap box fan, but oh well. The video is proving a point though. It's not worthless. The reason I'm doing this is largely in part to show that a little bit of effort into the repair can fix most things that people just toss out because they don't want to be bothered with it. And I tend to think that's kind of a poor mentality. I mean, granted, most people don't have the know-how to do what I'm doing here. You know, but even so, none of it was, well, I guess going to the motor is kind of complicated, but yeah, I don't know. I just would much rather fix something than toss it out, even though it could be, even when it can be usable, even if it's somewhat difficult to fix. But anyways, yeah, so we're ready to just about wrap this up here. I'm not exactly sure how the switch is going to go. It's going to fit through the hole just fine, but I don't know if this is going to be good enough to keep it from spinning around when you turn the dial. So we may have to figure something else out here. Is this not a... No, it's threaded. The current struggle is trying to get this on to the switch. There we go. Let's see if I can tighten this up here. Oh, I guess that will go tight enough. Okay, so now, let me make sure that's in the left position. I'm not sure what position it's in. Okay, so that's off. So this needs to be set up such that the 0 is facing the indentation. And technically we have kind of an infinite range of rotation that I could screw the switch into. Oh, Tisk, I can't tighten it with this on. I gotta move it first. I'm going to move it over just a little bit, just like that. And now we're going to tighten. And I think this will be okay. Okay, it's like 3 degrees off. And it's going to bother me, so I'm going to go ahead and fix it. Perfect. That seems to hold just fine. And it's sitting down really flush right up against the surface there. It's a pretty good fit. Alright, so now we just gotta get the wires in place. And this I guess I'll just leave this as it is. If I can use a smaller nut. Not that one, that's not going to work. Let's see here. This one may work. And it's the same color, how fitting. Nope, that one's not going to work. Must be too small. Let's try this one. That'll work. And this will just have, excuse me, to sit up here like this. Looks like our sticky stuff is still good. So we'll just reattach that right where it was. I don't know what kind of material that is, but it's powerful. And this isn't perfect here, this extra lead wire and whatever, but it's going to suffice, all things considered. This is just not going to be a perfect fan. Now my biggest concern here is making sure that this does not enter into the path of the blades. And it looks like this, if I do it like this, kind of stuff it back up like that, I think it'll be okay. What's not going to be okay is the fact that that just came out of there. That needs a little bit more slack. Now, I was not expecting this to be an issue. Can't really get it any more slack. You know, I think the easiest way to fix this is just going to be to put another junction on here and stuff the wire in, because I'd have to redo the strain relief and everything, and I'm not doing that. You know, to cut it to fit. Alright, I got a piece of 14-3 solid wire, and admittedly we're kind of starting to get into the realm of hackery here, but I just can't be bothered with this thing anymore. So this is what I'm going to do. And this is kind of better anyways, because this piece of wire will fit into the switch better than a stranded piece of wire will. So I'm going to strip this back a little bit more. Turn this up because that's going to cut through. And of course now it's too long. So I'm going to connect these two here like this. Actually what I want to do is kind of bend this way. So it's going to kind of sit like this and then go into the switch from there. And yes, it is kind of getting a little bit towards the hackery side of things, but it'll be okay. Alright. And it's a little bit too long. It's not really an issue, but I'd feel better if it wasn't that long. So I'm just going to pull it back out real quick and just cut a little bit off. Alright, I'm more confident with that. Alright, so this is what it looked like now. Actually, that's pretty good. I like that. Okay. Whew, that was rough. Okay, now let's get the... Well, you know what? Let me just do one more test to make sure that it's working. I don't really see any reason why it wouldn't be, but you never know. This isn't live at all. Of course, this isn't really a good way to test that, but whatever. Alright, that seems to be working. The handle. These are kind of tricky to get on. Actually, that went on really easily. I guess they're harder to get off. Alright. And now, wiring is going to be a little bit it's getting late. This wiring is going to cause a slight bulge in the guard, but it's whatever. I can't do anything about it. Now I gotta find where I put all the screws. Oh, here they are. That wasn't too bad. And since this video is already unreasonably long, I'm just gonna screw these in real time, because I don't think I'm gonna even bother editing any parts out of this video, because it's never going to come down to a reasonable length. I think we may be crusting 2 hours at this point. Oh, there's a couple broken slats here. I didn't see that. I would have glued those back together when I had the glue out. Oh well. There's a little dent in the thing here. Well, let's see if we can fix that. No, it's not going to bang out easily. I'd jack up something else. In the time being, I haven't banged it that hard. Nah, it's just going to stay. Oh, I saw some piece of metal fall in here. Here it is. I'm going to have to blow out at me. Alright. The blade, I did file down, not very well I guess, but I filed down some of the sharp points because you'll hear that as the blade is going around. So I filed that down and attempt to keep the noise to a minimum. It didn't seem too bad when I tested it before, so hopefully it'll be okay. And that piece right there is still a little jagged. Whatever. It's better than it was. And sometimes all you can ask for is improvement. Okay, that went on pretty nicely. And there should be adequate clearance between the blades and the wiring, I think. And now for the front guard. Oh, I used this new brush today, cleaning this up. And it worked pretty well to clean the guards. I was very happy with that. Actually, it's probably faster than dragging out the pressure washer and mixing up the condenser cleaner and everything. I just used some diluted ammonia D. I let it soak for a few minutes, and then I scrubbed it with that brush, and all the dirt came off quite well. I think that's going to be the new method I use regularly. I did that on the Ultra Force box fan as well, and I found it worked well. So, get the last 4 screws in here, and then I can go to sleep and not have to think about this project anymore. I think I missed a spot over here. Even works dry. Not bad. I don't even know where the hole is for this. It's not even anywhere near being lined up properly. I don't know if this, maybe the frame is bent or something, who knows. Alright, there we go. Here's the final test. Starting off on low. It's got a little bit of a startup sound. The blade's a little noisy. You can hear the, I don't know if it'll pick up in the camera, but I can hear the high frequency whirring of those chips. It's not terrible, but it's definitely noticeable. It doesn't shake too bad. Something's vibrating. It's right here. Alright, seems to be running pretty well. Let's go up to medium. And high. Spin down. Spin down time isn't as good as I'd like it to be, but there is no chance of me going back in there and servicing that motor again anytime soon. So that's it, the Lasko Cool Colors box fan from the trash. some glue, a couple dollars for a new fuse, and a new switch. It's good as new. So that just goes to show people throw stuff out that's still plenty good, after a couple of repairs.